Hi, I'm James Nicodemus. In this week's demonstration, we're going to go through the various electron domain geometries here. So we're going to start with where we have three electron domains, and this is with the trigonal planar. So there's three, it's kind of a shape of a triangle here. And the second part of this too, we'll go through and show on PowerPoint too what some of the molecular geometry looks like with the whole molecule. But when we have, this is an AB2 molecule, there is one lone pair on this one. So when there's a lone pair on top, the two domains sit like that, and we get a bent shape for this one. That's the one for the three. Okay, for our next one, we have four domains on this one, and this is the tetrahedral formation. So we have four domains in this one. When we have, and for our first one, we'll have the AB3. So let's take away one of these here, and that we'll have one lone pair, and we'll end up with the trigonal pyramidal. So it's kind of formed, they kind of bent down. We have one lone pair on the top, and then if we have two lone pairs in the tetrahedral formation, this would be the AB2, and we have the two lone pairs on the top, and then we would get the bent molecule once again on that. So that's for four. Okay. So when we have five domains, this is the trigonal bipyramidal. And this one here, so we can see all five, this one will actually kind of stick out just a little bit like that. So in our first molecule shape where we have one lone pair, this would be an AB4. So our lone pair end up in the middle, and we get what's known, I'm going to pull this out, as a seesaw shape. So this one here, yeah, that's a pretty good example of that. So that's the seesaw shape. One lone pair. If we have two lone pairs, then we end up, and this would be the AB3, and this would give us a T shape here. So the two lone pairs would be over here on the side, and we get this T-shaped one. And then the last one for the five domains in the trigonal bipyramidal is if we have three lone pairs, then we end up with the linear shape. We have one here, and one here, and then it would just be straight up and down. So that's for the ones with five electron domains. Okay, and then for our last demonstration here, this is if we have six electron domains. This is an octahedral, so there's one on the top, one on the bottom, and then four on the outside. So if we have an AB5, I'm just going to kind of hold it like this. This one we call the square pyramidal, and we have a lone pair on the bottom, and then we have four around the middle and one on the top. And then if we have an AB4, this one would have a lone pair on the bottom and a lone pair on the top, and this would be the square pyramidal. And then this would just be flat, four each one.
So with our three electron domains, this is our trigonal planar. We have the type of molecule we have here is an AB2. So A being the center molecule and the B's being the two atoms that are bonded to the center molecule. So a good example of this one would be the bent shape, sulfur dioxide. We have one lone pair on the top, which kind of pushes down those two oxygens and gives that molecule its bent shape. So that's the three electron domains. In the four electron domains, or the tetrahedral shape, we have the AB3 with one lone pair. So we have three atoms connected to a center molecule with one lone pair on the top. This shape gives as trigonal pyramidal, kind of a tripod shape. Ammonia is a good example of this one. In the four electron domains with the tetrahedral, we have the AB2. So this one here, this is a water molecule. So we have a center oxygen with 2 hydrogens here. There's 2 lone pairs on the top, which push down the 2 hydrogens on the side and give the molecule its bent appearance. Now with the 5 electron domains, this one we call the trigonal bipyramidal. This one has 5 domains. This is an AB4, so there's 4 connecting atoms to this center atom here with 1 lone pair. So sulfur tetrafluoride, here's a good example of this one, and it gives it a seesaw-shaped appearance. And it has 1 lone pair over here on the side, which kind of pushes those all down a little bit. 5 electron domains in the trigonal bipyramidal with the 2 lone pairs, the AB3 here. This one has a T-shaped molecule. This is a chlorine trifluoride molecule. And this has kind of a, as you can see, a T shape here with 2 lone pairs. In the trigonal bipyramidal with 5 domains, if there's 3 lone pairs, this is an AB2, so there's 2 connecting molecules. This molecule here on the bottom is a iodine fluoride, and it has a linear shape there. So there's 3 lone pairs, 2 atoms connected to a center atom, and this has a straight linear appearance. Now the last domains here, this one has 6, and we call this one an octahedral. So this AB5 with one lone pair has a square pyramidal. So it's square on the bottom with 1 coming off the top here. There's 1 lone pair. This is bromine pentafluoride. This has 1 lone pair and then 5 atoms connected to that center molecule. So there's 5 fluorines on the outside and then 1 bromine in the middle. And then our last example, this is of the octahedral with the 6 electron domains, is the AB4 with 2 lone pairs. And this has a square shape. This one they call the square planar. Xenon tetrafluoride is a good example of this. There's 2 lone pairs. They kind of push everything down flat and give it a nice square appearance. And that is how many of these molecule shapes get their geometry. So thank you for watching, and then we will see you again next week.